we're going to talk about equations of circles. And this is going to look kind of scary for a couple minutes, and then it's going to get real simple, okay? So we're going to write the equation of a circle. We're going to use the equation of a circle. On a coordinate plane, circles have equations just like lines have equations, and parabolas have equations, and all kinds of other things have equations, all right? The equation of a circle, like an equation of a line. If you know the x-coordinate of a point that's on a line, you can put that number in for x and then figure out what the y-coordinate of the point is, right? It's the same idea with the equation of a circle, okay? Now, here's where it comes from, and this is the scary-looking part. To find the equation of a circle, since all points on a circle are equidistant from the center, you can find an equation of a circle by using the distance formula. Let the ordered pair xy represent a point on a circle centered at the origin. The origin is 0, 0. And if you do that, so look what they've done here, okay? You've got the center of the circle at 0, 0. You've got a point on the circle whose coordinates are xy, okay? And if the coordinates of that point are xy, that means if you start at the origin and move over a distance of x, and then up a distance of y, you reach that point, right? Since I went over to the right in this example and then straight up, it's a right angle, isn't it? Now, from the origin, from the center of the circle to the circle, we've always called that the radius. So r for radius. Well, then the Pythagorean theorem tells us then that one leg squared plus the other leg squared equals the hypotenuse squared. So x squared plus y squared equals r squared. That's an equation of a circle. X squared plus y squared equals whatever the radius is squared is the equation of a circle whose center is at the origin. Okay? Now suppose that the center is not at the origin, because they're not always going to have the center at the origin, but instead the center is the point with coordinates hk. You can use the distance formula to develop an equation for this circle. All right? Here's how. Here's the distance formula that we all had memorized at one point, right? D for distance, not for diameter. D for distance. Okay, now here's what we're going to do. If we start with, let's see, let's call the distance r for radius, okay, equals the square root of. So what's the distance between this x-coordinate and this x-coordinate? Remember now, it's not 0 anymore, it's h. Well, it's x2, x minus x1, h, quantity squared, and then plus, and then what's the distance in the, or what's the difference in the y-coordinates from here to the center? The center's not at 0, 0 anymore, okay? So it's y2, y minus y1, which they told us was k. Square both sides, and now that's squared, and the square root sign is gone. So now we have x minus the x-coordinate of the center, quantity squared, plus y minus the y-coordinate of the center, quantity squared, equals the radius squared. And that's the equation you need to memorize. That's called standard form, or it's called center radius form. For us, it's the only form of an equation of a circle we're going to learn, so it's the equation of a circle. It's x minus h, quantity squared, plus y minus k, quantity squared, equals the radius squared. H is the x-coordinate of the center. K is the y-coordinate. of the center, and I'll write it down even though I hope you already know it. R is the radius. So none of us would have thought of coming up with an equation of a circle the way the book came up with the equation of the circle, but they did. And even if we didn't really completely understand every bit of it because we wouldn't have thought of it ourselves, that's okay, because now we know what the equation of the circle is. Okay? Now, when you write your equation, H will be replaced by a number, K will be replaced by a number, R will be replaced by a number. The variable X and the variable Y will still be in the equation. Just like with the equation of a line, right? When you were through, like you had y equals mx plus b, you replace m with the number, you replace b with the number, x and y were still in your equation. It's going to work out the same way. Let's do something. On page 746, write the equation of each circle. So for number 1, we have the center of the circle at the point 90, and the radius is 5. All we have to do is substitute the information they give us into our standard form for the equation of a circle. So we'll have x minus, and then h represents the x-coordinate of the center. What number is the x-coordinate of the center? 9, quantity squared, plus, parentheses, y minus, and then k represents the y-coordinate of the center. What number is the y-coordinate of the center? 0, quantity squared, equals r. R represents the radius, which is 5 squared. And then simplify a little bit. Do not bother squaring that out. Leave it in the form x minus h quantity squared, plus this one we need to simplify though, because y minus 0 is just y squared equals, and what's 5 squared? And that's it. We're done. Number 2. Once again, we use x minus h quantity squared plus y minus k quantity squared equals r squared. Hey, they didn't give us the radius this time. What's the radius? Now we have everything we need. So, x minus 3 quantity squared plus y minus 1 quantity squared equals 7 squared. There's only one thing to simplify. What is it? The 7 squared. And look, after you've done a few of these, if you can go right to the final answer, I'm fine with that. Okay? So far, so good. So was I right? It looked scary at first. Turns out to be easy. Okay. Number 3. The center is at the origin. What's the origin? 0, 0. Oh, they don't tell us the radius or the diameter. But it passes through the point 2, 2. Can I find the radius? The radius is the distance from the center to the circle. So can't I just find the distance between the point 0, 0 and the point 2, 2? Right? So I'm going to call it r for radius equals, then the distance formula, square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So the radius equals the square root of 2 minus 0 is 2, 2 squared is 4. Same thing happens again. So r equals the square root of 8. Now do we have everything we need to write the equation? Yeah, as long as we know the coordinates of the center and the radius, we have everything we need. So now we write the equation. So that'd be x minus 0 quantity squared plus y minus 0 quantity squared equals the square root of 8 squared. Everybody with me? All right, now this one we need to simplify quite a bit. That'll just be x squared plus y squared. And what's the square root of 8 squared? 8. All right, you ready for number 4? Do this thing. All right. We know the center, so we don't have to figure that out, but we don't know the radius. How are we going to figure out the radius? Same way we just did with the distance formula. The radius is the distance from the center to a point on the circle. So, x2, 1, minus x1, negative 5, quantity squared, plus y2, negative 4, minus y1, 3, quantity squared. All right, let's see, that'll be 1 plus 5, which is 6, 6 squared is 36. That'll be negative 4, or that'll be negative 4 minus 3 will be negative 7. Square the negative 7, that's 49. So the radius is the square root of 85. You guys with me on finding the radius? Okay, now, x minus negative 5, quantity squared, plus y minus 3, quantity squared, equals the square root of 85 squared. And we've got a little simplifying to do. We don't want to leave minus negative, do we? So x plus 5 quantity squared plus y minus 3 quantity squared equals, and what's the square root of 85 squared? 85. All right, we're still doing okay? All right, sometimes they're going to show us a graph, and then we still need to do the same thing. We still need to know the coordinates of the center. We still need to know the radius, okay? On number 5, we've got the coordinates of the center, 2, 1. Do we know what the radius is? It's going to be 2, okay? And one way I can get it is I can say, oh, well, that's a radius. That's 2 spaces. But it also, like if it was 2.01 spaces, I'd never notice the difference, right? But look, so let's look at this radius. It goes from the point 2.1 to the point 4.1. Since it's a horizontal segment, can't I just do 4 minus 2? And the radius is 2. So it really is 2, isn't it? Okay? So now that we know the center and we know that the radius is 2, we're in business. So x minus 2, quantity squared, plus y minus 1, quantity squared, equals, and if I want to save myself one line's worth of writing, instead of 2 squared, I will put 4. Now, on number 6, don't get the radius just by counting spaces, because I don't know if it's 3.5, 3.49, 3.7, right? I mean, I can't tell. So we need to find the radius, like we've been doing, like using the distance formula. So, radius equals square root of 0 minus 3 squared, minus negative 4 squared. So negative 3 squared is 9. Let's see, negative 6 plus 4 is a negative 2. Square the negative 2, you get 4. So the radius is the square root of 13. So x minus 3 quantity squared plus y minus negative 4 quantity squared equals the square root of 13 squared. And I need to simplify that a bit. That'll be x minus 3 quantity squared plus y plus 4 quantity squared equals 13. And that's pretty much any way they're going to ask you to come up with an equation of a circle. Okay? As long as you know the coordinates of the center and the radius, you can write the equation. So every now and then they're going to make you do some work to get that information, but that's all you need. Any questions? All right, well, our other learning target was to use the equation of a circle. So let's see how that works. It says use the equation of a circle. For each circle with the given equation, state the coordinates of the center and the measure of the radius. Then graph the equation. And your graphs of these circles they're going to be pathetic. They're going to be kind of squarish sometimes, or they're going to be, but that's okay. We don't expect the perfection here. So look at number 7. And I recopied our standard form, x minus h quantity squared plus y minus k quantity squared equals r squared. So first, let's get the coordinates of the center. If that gives us the x coordinate of the center, if h is the x coordinate of the center, what's the x coordinate of the center? 3. Now we've got to do a little bit of work to get the y coordinate, because our standard form says y minus k, and our equation says y plus 2. You got to think of it as a minus. Or so what's the same thing, using subtraction, what's the same thing as adding 2? Subtracting negative 2. So k is negative 2. And on the right side of the equation isn't r, it's r squared. So if r squared equals 16, what's r equal? 4. Now we can graph the circle, okay? So I don't even care if you have a coordinate plane or not. In fact, I'll just do this. Just make you a little coordinate plane. The point 3, negative 2. 1, 2, 3, 1, 2. So about right there is the center of the circle. Now, to get a radius of 4, just make a few examples. For instance, 1, 2, 3, 4. That point would be on the circle. 1, 2, 3, 4. So at that point, 1, 2, 3, 4. So at that point, 1, 2, 3, 4. So at that point, maybe that's why everybody ends up having square circles, is because didn't you do that? What you're trying to do is more like that. And what I'm going to do is completely cheat and do that. Uh-oh, I accidentally erased my coordinate plane. Okay? So, I'm not real concerned about the graph. I want you to be able to make a rough graph, but graphing circles just isn't easy. They don't look like circles quite often. But you with me? All right. Number 8. We need to find the coordinates of the center, and we need to find the radius. What's the x-coordinate of the center? 0. If it's x minus h, and then it shows up in the equation as just an x, h had to be 0, didn't it? So x minus 0, 0. And what's the y-coordinate of the center? Negative 1. All right? Y minus k, and then since we see y plus 1, that must be really y minus negative 1. So negative 1's the y-coordinate. And what's the radius? 2. Okay? So 0, negative 1, radius of 2. That's about as good as I can do graphing a circle. All right. Questions? All right, I got a question for you. What if, instead of a 4 over here, that had been a 7? Then what would the radius be? Square root of 7. How would you graph that? You're going to have to estimate. You're going to have to estimate like crazy. Square root of 9 is 3. All right, so square root of 7 is going to be smaller than 3. So just make a radius a little bit smaller than 3. And that'll have to be good enough. Okay? All righty. Page 746, do 1 through 8, 11 through 24, 27 through 29, 34, and 41 through 50.